Welcome back to the Deep Dive. We're here to cut through the noise and really focus on the insights that matter. Today, we're tackling a huge one. Global transportation. It affects everything, our planet, how we live, how we connect. We all know about the Paris Agreement. Those big goals keep warming well below 2 degrees C, aim for 1.5. But let's be honest, the transport sector, it's a massive part of that whole climate picture. Can we actually move more, connect more, but, pollute less?
That's the critical question, absolutely. And to help us unpack it, we're diving into a really detailed, forward-looking piece of research. It's called Global Transportation Demand Development with Impacts on the Energy Demand and Greenhouse Gas Emissions in a Climate-Constrained World. Quite a title.
It certainly is.
But what it does is provide this robust framework. It outlines how the entire global transport sector could potentially hit a 100% renewable transition, the goal. Net zero greenhouse gas emissions by 2050.
Net zero by 2050. Wow, that's ambitious. Okay, this study sounds comprehensive.
It is. It rigorously breaks down how we might actually get there.
So to really get our heads around this challenge and what the study aims for, let's set the scene. What was the starting point, say, back in 2015? And what future did this research map out?
Right. The 2015 numbers really show the scale. Back then, transport, it used up 19% of the world's final energy demand. That's roughly 31,080 terawatt hours, TWH.
That's huge numbers. And the emissions.
Yeah, staggering. About 8,260 megatons of CO2 equivalent. MTCO2 and almost all of that energy, it was coming from fossil fuels.
Okay.
So the study's core mission was, well, twofold. First, project how much transport demand is likely to grow between 2015 and 2050. And second, demonstrate a viable path using alternative tech, sustainable energy to meet that demand, but get emissions down to zero.
Right, and that's the double challenge, isn't it?
Yeah.
We're not just cleaning up what we have now.
Exactly.
We're dealing with a sector that's expected to grow.
Yeah.
A lot. How much more movement are we talking about globally?
The projections are, frankly, dramatic. This study suggests global transportation demand is set to roughly triple by 2050 compared to 2015. Yeah. If you break it down, passenger activity, up 260%. Freight, up 210%. It's massive.
What's driving that kind of growth?
Well, it's pretty much what you'd expect. Economic activity, GDP growth, population increase, globalization, more industry, more cities, basically more people moving more stuff, connecting more places.
So, okay, 2015, this massive growth is starting. What was actually powering all that movement back then?
Overwhelmingly, it was oil, fossil fuels. The data's stark. More than 92% of transport energy in 2015 supplied by oil.
92%.
Yeah. Natural gas was about 3%. Electricity, just 1%. And other fuels, like biofuels, are around 4%.
Yeah.
Think about it. Roughly 28,840 TDWSOs of final energy from fossil oil alone. A huge dependency.
And that dependency, what did it mean for greenhouse gases, the climate impact?
Well, it translated directly into significant emissions, made the transport sector a major climate player. Like we said, around 82.6 MECO2U in 2015. That's about 14% of all global greenhouse gas emissions.
14%, just from transport.
Exactly. It's a huge slice of the pie. And that's why transforming the sector isn't just, a nice idea. It's essential.
And if we look inside transport cars, trains, ships, planes, which mode was the biggest part of this energy use and emissions problem back in 2015?
No real surprise here. Road transport, it was dominant, accounted for 76% of the total final energy demand in 2015.
3/4, just roads.
Yep. And within that, passenger cars, light-duty vehicles, or LDVs, they were the single biggest source of greenhouse gas emissions. So that gives a clear target for where change needs to happen fastest. Right?
Exactly points a finger.
So to handle this booming demand while somehow getting emissions to zero, this study maps out a radical shift, the core idea, the engine driving this whole scenario. They call it direct and indirect electrification.
Okay, electrification. That sounds familiar, but let's get into the nitty-gritty. What does that actually look like for our cars, our trains? What about ships and planes? How does it change things?
Okay, let's break it down, mode by mode. First, road mode. Biggest challenge, as we said. Here, battery electric vehicles, BEVs, and fuel cell electric vehicles, FCEVs, using hydrogen, they're pinpointed as the most promising tech. And the key thing, efficiency gains. Huge ones.
More efficient how?
Well, this study projects BEVs need the least final energy per kilometer, then FCEVs, then plug-in hybrids or PHEVs, and way behind them, traditional internal combustion engine vehicles, ICEs.
Okay, so technically better.
Yeah.
But what about cost? Does it make economic sense?
So that's where the study uses something called levelized cost of mobility, LCM. basically the total cost over the vehicle's life. And the analysis shows BEVs become the least LCOM option, the cheapest for most road segments from 2025 onwards.
2025, that's practically now for cars, buses.
Yeah, for light-duty vehicles, buses, medium-duty vehicles, it's happening fast. And it's not just theory. Look at Shenzhen in China. They hit 100% electric buses, BEV buses, by the end of 2017. Proves the economic case for buses is already there today. Now, for the big trucks, heavy-duty vehicles, HDVs, it's closer.
Right.
BEV and FCEV costs look very similar, so likely they'll coexist.
And the old gas guzzlers, ICEs.
They quickly become the most expensive ELSCOM option from 2025, so the study predicts a really rapid drop-off in new sales.
So you're saying in just a few years, seeing a regular gas pump for your car might start feeling old-fashioned? That's a huge shift.
It's a massive societal shift, absolutely, not just technology. Okay, next, rail mode. Rail's already kind of the efficiency champion, least energy-demanding mode.
Right.
The study sees electrification just continuing to increase, reaching about 87% electricity share by 2050. The rest would be liquid fuels, but even those need to be, defossilized biofuels or synthetic fuels.
Okay, rail seems relatively straightforward, maybe just more of the same good stuff, but
Yeah,
the big ones. Shipping, aviation, those are almost entirely fossil fueled now, right?
That's very
And the distances.
yeah.
How do you electrify container ship going across the Pacific?
You've hit the nail on the head. The hard-to-abate sectors, they're the tough nuts to crack. So for marine transport, currently, almost all liquid fossil fuels. The future looks very different, though. Electric ships, they actually look good for shorter distances, up to maybe 100 kilometers.
Okay, coastal stuff, ferries.
Exactly, and that covers something like 80% of domestic shipping potential. It's significant. For the long haul, the transoceanic routes, that's where hydrogen and LNG, liquefied natural gas, come in. Hydrogen might well end up dominating that space as the tech matures.
Hydrogen ships
Interest.
and planes, aviation.
Yeah.
Currently 100% jet fuel.
Also a huge shift, but maybe starting a bit later, around 2035, according to the study.
Yep.
You'd see electricity powering shorter flights, maybe up to 1.5 to 3 hours, 100 passengers or so. Think regional hubs.
So electric planes for short routes.
Yeah. For the longer distances, again, hydrogen looks crucial, alongside electricity-based synthetic jet fuels, e-fuels. Now, the challenges are massive for both shipping and aviation, no doubt, but these electric and hydrogen options, they offer really substantial efficiency improvements over just burning jet fuel or bunker fuel. That makes the transition compelling, both environmentally and eventually economically.
That's
Yeah.
quite a transformation across every single way we move. Cars, trains, ships, planes, all fundamentally changing. So we've got this huge growth in demand, but all these tech shifts. What's the bottom line? What does it mean for overall energy use and the big one, emissions?
Right, and this is where one of the study's most, frankly, surprising results comes in. Despite transportation demand tripling from 2015 to 2050,
Yeah.
the final energy demand for the entire transport sector stays almost stable.
Like what? Triple the movement, but the same energy use?
No, it seems counterintuitive, right? But it's the direct result of those massive efficiency gains we talked about, primarily from electrification. Electric motors are just way more efficient than combustion engines. Plus, things like regenerative braking, lighter materials, smarter logistics, it all adds up.
Okay, that's incredible. Less energy, or rather the same energy, for vastly more movement. That efficiency point is key.
It's absolutely central to the whole scenario.
So what about the fuels themselves? If it's not mostly oil anymore, what are we using in 2050 in this scenario?
It's a complete flip. Remember, 2015 was nearly 98% liquid fossil fuels.
Yeah?
The 2050 projection is 35% direct electricity, 25% hydrogen, about 6% LNG. And the remaining 33% is liquid fuels, but, and this is crucial, they're defossilized,
Defossilized meaning.
meaning biofuels or synthetic fuels made using renewable electricity. So no more crude oil powering our movement. It's a total overhaul.
Yeah. And the study looks upstream too, right? The primary energy source. Where does all this electricity and hydrogen come from?
Exactly, and that's maybe the most fundamental shift. From 95% fossil fuels dominating primary energy for transport in 2015 to 98% renewable electricity dominance by 2050.
98% renewables.
Yeah, powering everything either directly as electricity or indirectly to make hydrogen or synthetic fuels. And because of this shift in the vehicle efficiencies, the overall system efficiency, well-to-wheel they call it, improves a lot. Goes from about 26% in 2015 up to 39% in 2050, less energy wasted from start to finish.
Okay, all these changes, efficiency, new fuels.
Yeah.
It all points towards the main goal, cutting emissions. So what's the timeline? When do we hit zero greenhouse gases in transport, according to this study?
The projection is that emissions from the transport sector peak sometime between 2025 and 2030, so pretty soon. And then they decline steadily, hitting zero by 2050.
Zero by 2050.
Yeah.
Is that realistic?
Well, the study argues it's technologically and economically feasible based on these pathways. It's incredibly ambitious, requires massive coordinated effort, but the pathway is laid out. But there's another crucial point about emissions. As road transport cleans up faster,
Yeah.
the responsibility or the share of remaining emissions shifts from around 2040 onwards, marine and aviation. They become the dominant emitters. More than 50% of the remaining transport emissions will come from them in the later years.
So the pressure really mounts on those hard-to-abate sectors later on.
Immense pressure. They absolutely have to accelerate innovation and adopt these defossilized solutions.
Okay, this all sounds incredibly transformative, almost utopian in a way. But surely there are bumps in the road, new challenges this creates. Does the study flag any potential issues?
Oh, it definitely does. While a tech path looks clear, there are big questions about resources. We're talking about materials needed for all these electric motors and batteries, things like neodymium, dysprosium, lithium,
The
cobalt.
battery metals we hear about.
Exactly. Can we source them sustainably? And crucially, can we recycle them effectively? The study warns that without near-perfect recycling rates close to 100%, we could face depletion issues for some materials, like lithium, maybe in the 2060s or even sooner. There's also mention of silver used in solar panels, which ties into the massive need for renewable electricity. Ensuring the whole supply chain is sustainable is critical.
So new dependencies, new resource challenges to manage carefully.
For sure, it's not just about the vehicles, it's the entire system supporting them.
So to wrap up this deep dive, this study, Global Transportation Demand Development with Impacts on the Energy Demand and Greenhouse Gas Emissions in a Climate-Constrained World. It paints this picture where we can triple how much we move globally, but do it with roughly the same amount of final energy and, crucially, hit zero emissions by 2050. It all hinges on this radical shift towards electrification and efficiency. It's quite a vision.
It really is. And what's powerful is the argument that this pathway isn't just wishful thinking. It's technologically feasible and, importantly, becoming economically viable, driven by falling costs for renewables, for batteries. And it's but it requires just monumental effort across sectors, governments, industries, individuals too. The tech is emerging, the economics are shifting, but the scale and speed needed, that demands unprecedented commitment.
And that leads perfectly into the final thought the study leaves us with. It's something beyond just the tech and the economics. While this research, Global Transportation Demand Development with Impacts on the Energy Demand and Greenhouse Gas Emissions in a Climate-Constrained World, outlines what's possible, it also hints at something bigger. It actually references movements like Fridays for Future, the scientific consensus on urgency. It suggests that hitting these incredibly ambitious goals, maybe even faster than 2050, really depends on what it calls a societal tipping point. So the question we want to leave you, our listener, with is this. Are we collectively ready to make that leap? Not just adopting the technology, but demanding and driving this transformation with the urgency our climate-constrained world clearly requires. Something to think about.